Hello everybody, we are going to start, and today we will tell you about capabilities of the latest Equip software version. Equip software is designed for strength and stability analysis for pressure vessels, columns, tanks, and heat exchangers. We will show you how you can use Equip for vessel and column analysis, heat exchanger and tank modeling. We will also tell you about seismic and wind loads assessments in Equip. And one more topic for today is supported codes, as well as integration capabilities of our software. During the webinar, we will also ask you to respond to a poll because we want to better understand who has joined us today, what specific needs you have, and how we can improve our software to make it even more comprehensive. And today we have Andrei Krasnokutsky, the head of the Strength Analysis Department, as the webinar presenter. Andrei, we invite you to start the webinar.
Thank you, Marina. Hello, dear colleagues. As already mentioned, my name is Andrei Krasnokutsky, and I am the head of Equip FM software development group. Equip FM software consists of two programs, Equip and Nozzle FM. As you know, all calculation methods can be divided in two types, so-called design by rules, early design by formulas, and design by analysis. Design by rules. This is the vessel calculation of strength, stability, buckling, tightness, and others using formulas. The formulas are in the standards such as ASME 8, Division 1, Division 2, EN 13445, and others. The calculation is carried out for certain standards elements such as shells, heads, nozzles, flanges, supports, etc. If the construction is not described in any standards or the application conditions are not met, you must use design by analysis. Design by analysis is a stress calculation using numerical methods, mainly the finite element method. This method allows you to calculate almost any construction with any loads. The Nozzle FM is designed for stress and flexibility calculation mainly of nozzle to shank junctions using the finite element method, so-called design by analysis. Equip is a program that calculates the safety of vessel using formulas or design by rules. In this webinar, I present to you attention the vessel program. Let's start with types of equipment that Equip software helps to calculate. The Equip program is designed for calculating pressure vessels and apparatuses, including horizontal and vertical vessels, columns, heat exchangers, and tanks. It should be noted that all slides shown are models created in the Equip program. Now let's look at the input general data. First of all, you must choose the type vessel to be calculated. Horizontal and vertical vessels differ only the directions and supports. For horizontal vessel, saddle and bracket supports are used. For vertical vessels, legs, lugs, and ring supports. The column is supported by skirt, cylindrical or conical shape, or of the bottom bottom. Tank. This is a vertical vessel, usually a larger diameter, supported by a flat bottom on the foundation. After that, you set the number of vessel loads. For the same vessel, several loading cases can be selected. Operating, vacuum, cleaning. If there is a liquid, we set its density and volume or filling height. The program will automatically calculate the weight of the liquid and the hydrostatic pressure for each element to include it in the calculated pressure. The program allows you to calculate the test pressure for each element and vessel as a whole, depending on the selected code. Next, if necessary, we introduce the calculation of MDMT and accounting for temperature deformations. Now, let's look at the wind loads in Equip software. We select a standard according to which the wind loads will be considered. European, American, Mexican, Indian, and Canadian standards are currently available. The next version, Chinese and Uzbek norms, will be added. To calculate the pulsation component, the program determines the lowest frequency and shape of the oscillations. With automatic setting, the wind direction is set in the most unfavorable direction, but you can also choose the desired direction. The next feature is seismic loads. As in the case of wind loads, we select a standards tool, according to which the seismic loads will be considered. The lowest frequency and shapes of oscillation is also used in the calculation of the dynamic component. You can set not only the automatic determination of the lowest frequency, but also, if more accurate data is available, manually. Equip also can help to calculate underground vessels. To calculate the underground vessels, it's necessary to determine the external pressure from filling with soil. To do this, it's necessary to determine the density of the soil, the height of the filling, the angle of internal friction of the soil, and the load safety factor. Average value of external soil pressure taken into account when calculating the stability or buckling of the vessel. Equip supports mostly frequently used standards. The main calculation standards using the program are ASME Section 8 Division 1 Division 2, EIN 13445, API 650 for tanks, and Russian Ghost. There is a large database of materials and different elements, such as shells, heads, flanges, gaskets, saddle supports, supporting legs and lugs, skirts, nozzle, cross-section of ribs, reinforcing rings, etc. To calculate the nozzle from external loads is used WRC 537, former 107, and EIN 13445. When creating a model, the program checks the input data, and if required data are not entered, or data are entered incorrectly, outputs warning and or error message. In the edit window, maximum global working pressure and required thickness express calculation are output, including maximum stiffened length for external pressure. As I already said, there is a large database of materials including ASME 2 Part D, European, Chinese, and Russian standards. You can create a material with your own properties. To do this, choose the standard material as similar to your one as possible, copy it to the clipboard, paste it to user materials, and correct the necessary data. Another Equip capability is a 3D model representation. When creating a model, you get a detailed graphical representation of it. You can view a model in semi-transparent or wireframe display, enable-disable isolation, and fill display to better view the internal contents. You can also display dimensions, fitting labels, service platform levels, center of gravity locations, etc. Automatic calculations is one more software advantage. Everything that is necessary for calculation, such as weight loads, hydrostatic pressure, determination of the most loaded section, loads and supports, etc., the program will calculate itself automatically. The user only needs to create a model and set the loading conditions. Now let's look at calculation capabilities. If the diameter or pressure in one element changes, after a warning, the program will change these values and adjacent elements. The user can select any system of units, international, empirical, or customs. Temperature deformations can be taken into account in the calculations, which is especially important when determining the loads on supports and foundation. The diagrams in the report allow you to see deformation, bending moments, transfer forces, as well as safety factor for strength and stability. PASECUBE software supports export of a 3D model to different formats and programs. The vessel model can be exported in IGES, STEP, ASYS, Parasolid formats to AutoCAD and other popular CAD and finite element analysis software for creating drawings and further calculation if necessary. Composite structures. The program allows you to consider a structure consisting of several vessels as a whole. Two elements are used for this: a new coordinate system, so-called vessel assembly, and connection between elements, links. In this case, the connection can be absolutely rigid, set by section, manually or in the form of flexible link, steel cable. You can select any standard section profile or set it manually. Vessel of non-circular cross-section. The program calculates vessel with non-circular cross-section. At the same time, heads and perforations can be added to the model. Now let's look what capabilities the program offers for different types of vessels. Columns. The program determines the lowest frequencies and waveforms for calculating wind and seismic loads. It performs calculation of the strength and stability of the column elements from the received loads, including the skirt. The skirt can have a cylindrical or conical shape and include a transitional shell. Transitional shell may be used when we have different materials for skirt and bottom. The program automatically determines the position of the most dangerous cross-sectional skirt, taking into account the weakening by the holes. It also calculates the loads on the foundation and the supporting structure. Connections with steel ropes, with possibility per load. With the help of additional elements, such as connection node, attachment, flexible connection rope, you can create a model with pretensional cables. The program performs an iterative calculation of the forces in the cables. In the case of compressive load, this connection is disabled. Heat exchanger. The program calculates shell and tube heat exchangers with fixed tube sheets, with U-tubes and floating heads. It's also possible to calculate our cooling heat exchangers. For heat exchangers, may be used a so-called tube sheet designer. Tube sheet designer allows you to create sheets of up to 8 flows with almost any arrangements of the tube bundle. Tank. The calculation of the tanks automatically determines and take into account the weights of elements and the hydrostatic pressure depending on the location of the wall course. The strength and stability of the wall and the stationary frame's roof, including wind, snow and seismic loads, are calculated. The requirement for anchorage is established and, if necessary, it's calculated. The loads on the foundation are determined. Allowable nozzle loads. The API 650 method is used to calculate the strength of the tank nozzles. If the condition of API 650 method usage don't allow this, then it's possible to calculate the strength using the Pass Nozzle FEM program. Editor of tank frame roofs. The difficulty of calculating frame roofs lies in the fact that unlike wall and shell roofs, there are no analytical calculation methods designed by formulas. Such calculation is possible only by finite element method designed by analysis. PASECUBE has a frame roof editor that allows you to create not only a finite element model, but also loads in accordance with the requirements of the standard API 650. Then, through export, a file created for reading in the ANSYS program in which strength and stability are calculated. Currently, our group develops an internal solution to such problem without involving external programs. Now, let's look at report generation. After performing all calculations, the program generates a report in the form of summary tables and a complete report with intermediate analysis results. Summary tables include initial design data, load conditions, and results for all loading cases of shells, heads, nozzles, and flanges. This slide shows a fragment of a report of the calculation of flat cover with several holes. The program automatically determines the weakest section of the cover. Reference. This slide presents the main standards for the calculation of the vessel, heat exchanger, columns, and tanks. Various normative documents are also used to create a database on materials and vessel elements. In total, more than 70 documents are involved in the program. Examples. On this slide, you can see various examples of vessels created in the PassEquip program. Horizontal vessels, vertical vessels, and vessels with heat exchanger elements. Examples of heat exchangers. On this slide, you see examples of horizontal, vertical, with expansion bellows, and dual heat exchangers. And columns. This slide shows the columns and including double column mounted on a reinforcement concrete pedestal. Users. This slide highlights the key industries and major users of PassEquip software solutions. As you can see, our tools are utilized across a wide range of industries, including of refining, chemical production, petrochemical processes, oil and gas, thermal power generation, and more. On the right, we showcase some of the prominent components that rely on PassEquip software for their engineering needs. These include well-known names such as ThyssenKrupp, CNPC, Dalim, Hitachi Zosen, among others. In the first example, I show you how to calculate underground vessel. First of all, we input general data, and we need to input two load cases. First operating and second filling of the soil. In first operating cases, we input working fluid, in our case oil, with density 750 kilogram in meter in cube. And second load cases, empty, we need input zero density. After that, we input filling ratio. In our case, for example, 90%. Choose testing code, testing for code, ASME 8 division 1 UG 99B, and input hydrotesting a kind of test and test pressure 0.7. Calculate MDMT, lowest expansion temperature, for example, minus 30 centigrade. Used to compute the MDMT design pressure, not maximum global vacuum pressure. And after that, input condition for soil. Choose only filling of the soil here, and input density of the soil, load safety factor, and height of filling by soil, in our case 1 meter, and angle, soil and tone of friction. Yes? Okay. And we need to create our model. Beginning for shell, input codes, in our case division 1, SME 8. Materials, for large database, we choose from ASME, yes, 2 part D. Name of material SA516, type grade 16. It's plate, carbon steel. And we may look on properties from this standard and estimate allowable stress. Yes? Okay. After that, we input into inside or outside diameter, nominal thickness, corrosion allowance, negative tolerance, joint efficiency, and design conditions, design pressure and design temperature, and in operating case and in case of filling of the soil. Yes, in operating case, design pressure we input 0.5 megapascal, and filling we input vacuum. Not full vacuum, but half of full vacuum. It's minus 0.05. It's equal 0.5 atmosphere, because we system megapascal. And temperature, design temperature for operating 50 centigrade and filling 20 centigrade. Okay, design values calculation, and we can see that maximum allowable working pressure is more than 0.8 megapascal, and maximum allowable working pressure when we external pressure only 1.20 megapascal. Yes. And after that we create left and right heads. It's the same. Standards, materials, geometry, load conditions, input manhole. Okay, we can input additional calculation from external loads for radial nozzles, and input flat cover. Flange cover we input standard ASME B 16.5 for pipe flanges and flanges fitting. Okay. After that we input the same design conditions. Okay. And stiffness ring, we input 3 rings, distance between them 2 meters, and divide it on 4 elements. And after that, click on calculator, calculate our vessel from 2 load case in operating conditions and when vessel is empty. And we can see it as okay. Okay, from buckling, from condition, from strength conditions, for example, drawing forces, displacement, transverse force, moving, bending moment, and all loads on supports. Saddle support, fixed, sliding, supports force, automatically calculates. And after that we calculate shell with these loads, which we calculate from, we can see from drawings, yes, before. And operating, internal operating, it's input additional hydrostatic pressure, yes, and after that from ASME division 2 calculate all strengths and stability. And second conditions, filling of soil. In this case, calculation external overpressure is equal 0.07 megapascal. It's equal 0.5 megapascal from external pressure vacuum plus from filling of soil. It's equal 0.05. And in this case, shell calculates for external pressure vacuum plus from filling of soil and calculate all conditions, strength and buckling, and we conclude that it's okay, all cases. And hydrotesting conditions. Calculate from design pressure from hydrotest and plus hydrostatic when we fill our vessel. Yes, it's okay. And we can see filling our working fluid, and if you need options, setting, for example, internal finite element beam model, its displacement. And what else we can see? For example, foundation loads, yes, in sliding saddle support, and in fixing, it's fixing displacement 0. All loads on foundation we can see. And go to second. In second example, I show you how you can calculate, for example, steam chimney pipe with ropes extensions. Yes, it's the main task is calculate maximum extension load on ropes, on each ropes. The main loads is wind loads, and if we click here, options, general data, and choose wind loads, choose codes, for example, EN, terrain category, basic wind velocity, and other parameters. In our case, wind velocity is 75 km per hour. Okay. Create pipe, means code, material, diameter, thickness, corrosion allowance, yes, design temperature. It's chimney without additional pressure. Okay. After that, we create here click support, and we create additional 4 nodes with fixing. For example, here steel rope, but we need node, for example, 2 displacement of this node, yes, fixing this node. After that, we create on pipe attachments, here attachment, and this rope connection between attachment bracing and node. And rope is a flexible link, yes, with pretension we input, for example, 1 kilonewton. Next, we input geometrical parameters, its diameter, common diameter, and cross-section area of this rope, and long stiffness factor and low stiffness. Yes, okay. And we create 4 ropes, and after that calculate strength and stability, and maximum loads on all elements. Well, for example, we can see natural frequency and period. It's a shape of natural frequency. And after that, we calculate wind loads. Wind loads, it's methods per EN. For example, it's horizontal load, bending moment on our chimney pipe. And after that, we can see form, yes, form, which calculate, yes, and all loads, for example, maximum loads on steel rope number 4, we can see calculation axial tensile force equal 12 kilonewton. But in other steel rope, for example 1, for example 3, only 0.5 or 4 kilonewton. And loads on fixing loads as vertical vessel equal approximately the same, minus 11 kilonewton. And we can look on cylindrical shell, for example pipe, yes, all maximum forces on this element, and calculate on stress and buckling Henry Bednar pressure vessel design handbook. Yes, we calculate all positions with intermediate values, and we can see that's okay for strength and stability of this pipe. Yes.
So if you have any questions in the future, you may always contact us by email, by WhatsApp. You can see the contacts on your screen right now. And I would like to thank Andrei and everybody who has joined us today. Thank you and have a good day.